This is the fourth in a series of video-based lessons that will introduce the basics of object-oriented programming with Visual Basic. You will get a solid understanding of the major OOP concepts from classes and objects to inheritance and polymorphism. We will compare and contrast both pros and cons of procedural and object-oriented approaches to application development. This material can be found in Chapter 11 of the textbook. We will begin our Intro to OOP with definitions of classes and objects, including properties, methods, and events, all of which define the class interface. We will also show how the objects are instantiated and initialized from their class templates and discuss the role of object constructors. For examples of arrays, a few examples of arrays of objects, sort of like the arrays of structures from the beginning of the class, will be used for more realistic applications that need to process many objects of the same class. We will conclude with a few of the more advanced OOP concepts, such as inheritance and polymorphism. We will start with more of a conceptual rather than technical definition of a class. A class is a template for creating objects, kind of like a blueprint that lists all the characteristics or properties and behaviors or methods associated with the real things, object, the class represents. For example, a car class, shown in the top right corner of the slide, would have properties such as fuel level, max speed, MPH, color, num doors, style, make, type, year, etc., etc. Some of the behaviors, methods, would be drive, turn, set speed, get fuel, etc. A specific object of car class would be an Audi, Ford, or Toyota. An object, say Audi, is an instance of the car class with specific properties, such as make equal quattro, color equal blue, year equal 2030, etc., etc. We'll discuss these a little bit more a few slides down the road. In general, classes correspond to nouns such as car, dog, or loan. Properties are adjectives of those nouns such as dog color, height and weight, or loan amount, interest rate, and term. Methods are typically verbs describing various behaviors associated with class objects. For example, dogs can sit, come, shake, or lay down, as shown towards the bottom of the current slide. For more business-like classes and objects, such as loans, calc month MTH PMT for calculating monthly payment, get REM balance or get remaining balance, and calc INTR saved or calculate interest saved would be the methods or functions that manipulate properties or data to perform the required tasks. Finally, an instance of a dog class is an object of type dog, which would be a particular dog like Riney, I think, with specific properties, data shown on this slide as well. A particular instance of a business loan class would be an auto loan for a specific amount of $20,000, interest rates of 7%, and term of 5 years, as an example. There could be other auto loans or auto loan objects for different amounts with different interest rates and terms, as well as mortgages and other loan types. Over the next two slides, we digress briefly to discuss the pros and cons of procedural-oriented programming, POP or POP, versus object-oriented programming, OOP approaches. As we learned from Intro to Programming, IDSC 3101, breaking down a complex problem into simpler, more manageable tasks is the key concept associated with procedural programming. The so-called modularized design is a natural way of thinking about problem decomposition. It works well for more predictable, step-by-step problems, resulting in relatively fast code execution times. POP approach is not as well suited for unpredictable, user-driven applications because of a sheer number of possible interactions that need to be anticipated and responses to which need to be programmed. This tends to result in overly complex, difficult to manage programs where data is often exposed and much less secure. In addition, Despite the modular design, code reuse is relatively limited, with lots of copy-paste, which contributes to program complexity and degradation in performance. Object-oriented programming, on the other hand, is well suited for user-driven applications with unpredictable execution paths because it mimics the way we as humans interact with real-life objects such as cars or dogs, or business objects such as financial loans. In addition, the data is encapsulated/hidden within the instances of objects themselves and is exposed to the outside world in a very controlled manner, i.e. only when needed. OOP paradigm is built entirely with efficient code reuse in mind. When developing application programs with a set of classes available to you, you only need to understand how to interact with objects instantiated from those classes. That is, you only need to understand the interface, properties, methods, and events, and do not need to worry or know anything about the internal implementation of those classes. The classes essentially become like building blocks of your applications, which improves productivity and maintainability, no more code copy-pasting. It speeds up the development and delivers more robust, higher quality applications. Think of just using a well-defined business loan class with its properties, methods, and events. You don't have to worry how the properties expose/hide the data, how the methods do what they do, for example, calculate monthly payments, remaining principal, interest saving, etc. All you need to know is that when you create an object of a loan class, or more likely an array of these objects, is how to use them to create an application program that will accomplish the tasks you want to be able to do. There are drawbacks to OOP approach, chiefly one of the slower execution when compared to POP. From development standpoint, the learning curve is much steeper because of the often mind-boggling complexity of class/object hierarchies one has to learn in order to be able to efficiently and effectively use the classes when developing more complex business applications. For example, Microsoft Excel object model starts with the application class itself, which breaks into add-ins, windows, and workbooks. Workbooks divides into charts, names, VB projects, windows, and worksheets. Worksheets collection further subdivides into chart objects, comment, hyperlink, name, page setup, pivot table, and ranges. Ranges further break down into rows, columns, and cells. There are literally hundreds of Excel classes/objects, each with a number of properties, method, and events. If you Google Excel object model map images and click on one of those few of those images, you will see what I mean. Returning back to our main topic of object-oriented programming, this slide describes the difference between the two major types of objects, especially as they relate to Visual Basic environment you encountered thus far. The first group of objects, some of which you are very familiar with, are the so-called control objects. The individual form object FRM name has an associated public class FRM name where all the code associated with the form objects as well as general functions and procedures are contained within. We often refer to it, and will continue to do so, as our main program, or simply the main. Each of the individual controls, such as text boxes, command buttons, radio buttons, check boxes, list boxes, and combo boxes, are all examples of control objects. For example, txt name text box object is an instance of text box class, and the same goes for the rest of the more physical types of objects. All of these objects have predefined properties, methods, and events, and our event-driven programming journey from the beginning of IDSC 3.101 until now has mostly consisted of writing VB code using variables, decision structures, functions and subroutines, repetition structures, and arrays to, in large part, manipulate control properties and use control methods and events to design simple applications. In addition to these control objects, we will define and then use the so-called code object. You can think of those as user-defined classes and objects, the users being us, of course. This should sound familiar to the user-defined functions used in addition to already provided financial, math, and other functions when a specific task needs to be accomplished that nobody wrote the code for, or at least the code is not available in the existing libraries and templates. So, a code object will be instantiated from a newly defined class, such as the dog class. The code will reside outside of the main program, that is to say, a public class FRM named right below / after the end class keywords. The code will consist of properties we ourselves will need to define. These will look similar to data structure members, but will not be directly accessible, as you will see shortly. They will be exposed to the user in a controlled manner, which means that the data will be encapsulated in the object, and as such will be much better protected and secure. We will also need to define the methods through which the object will be able to perform certain actions, and finally the events, which if raised will have the object respond to in an appropriate way.